Hello everyone, my name is Mohammed Zahed Farooqui. I am a final year student in Deccan College of Engineering and Technology. I am making this video for the final assignment in Skyfi Labs. In this video, I am going to analyze and design a seismic resistant building. This seismic analysis is done on a tall structure which we have analyzed and designed in our previous assignment. So as you can see here, first thing we have to do is to unlock the model, then click OK. In this we are going to perform three types of analysis. First one is linear static analysis, then linear dynamic analysis, which is response spectrum method, then final non-linear dynamic analysis, that is time history analysis. So first we are going for linear static analysis. For that thing, first go to define load patterns. The first thing we have to do is design seismic load. So type the load as seismic, load type as again seismic, and we have to select the code book which we are using. In this we are using IS code. So select the IS code, IS 1893-2002, that is Indian Standard Code for earthquake loads. Then add new load. Then click on the load and modify lateral load. So this tab is open. First we are designing and analyzing a building for seismic waves for both in X and Y direction. So we have to check the box here. We don't have to use eccentricity. We can use it if we are doing specific location analysis. So we don't have to change that story range. Then the seismic zone factor. For the value of Z we have to go to the codebook. In this map we can see we are designing as the region is Bangalore, so Bangalore lies in zone 2. For factor we have to go to table 2 of Indian code 1893. Seismic zone 2 low, the value of Z is 0.10, so we have to write in this 0.1. Then site type. Okay, for site type that is type 2. We are assuming that the construction is done on a medium soil. So soil type 2. Importance factor. Next we have to see the importance factor, which is in the table 6. We are assuming that the building is a residential building, so the importance factor for that particular building is 1. So go to the tab and mention 1. Then we are clicking on the program to calculate the time period. We can do that manually by using formula, but program will automatically calculate the value. The next thing we require is the response reduction factor, that is R. For that again go to the codebook and see table 7 for response reduction factor. Our factor lies in one option, that is ordinary RC moment resisting frame. The value of R is 3. So entering the value 3. After making all the changes, click OK. After the seismic load is done, we have to click OK. Then go to define, go to load combinations, and say the load combination has been generated for seismic load. And click OK. Again going to define to check that load cases. In this we can see the seismic load is done as a linear static method. Then click OK. Go to analyze, click set load cases to run. In this we are doing seismic analysis, so we don't need to run wind load analysis. So click on that and click on do not run case option. So in this particular model the wind load will not run. Then click on the option run now. The analysis is done. We can see in the bottom window. Analysis is still going on. Yes, analysis is completed, we can view the animation by clicking the start animation here. Another thing, we can see all the displacement by moving our cursor in the 3D tab. So again, we can display and see the various stress diagram that a bending moment show. For example, I want to show moment, so click on that moment and click apply. The moment will be shown here. So we have to remove the extruded view. Okay, wait. These are the moments. So in the same way, we can display various stresses by going in this. We can use shear force and click apply. After analysis has been done, we have to design the structure. So click on design, concrete frame design. See that IS code is there, then click OK. Then design, start concrete design check. Wait for the design, it should be done. It takes some time because the building is huge. It is a tall structure of 23 stories, so we have to wait for a second. It is showing that 64 concrete frames is being failed. We have selected the auto select option for assigning the columns and beams. By clicking yes, it will reiterate the model. It again do analysis for the new sections of beams and column and again run design. After the analysis and design has been done, we can see that it will showing the longitudinal reinforcement bars in 3D view. The next thing we have to do is for linear dynamic analysis. For that linear dynamic analysis, we have to unlock the model. Click OK. After that, we have to define the functions for response spectrum method. In linear dynamic analysis, we are doing response spectrum method. For that, we have to go to define, go to load patterns, see that seismic load has been there and check the inner values that we are doing for x and y direction. Everything is same. Then click OK. Then again OK. Then again go to define functions, select response spectrum method. In that, choose the IS code in which we are using, that is IS 1893-2002. Then click on add new function. Then give the name function name as response spectrum. And select the damping ratio as per IS 1893 is 0.05, 5% for concrete sections. So write as 0.05. Seismic zone factor will be 0.1 as we have seen. Soil type as 2. And this is the response spectrum curve. Then click on OK. After the response spectrum function has been defined, click OK. Again go to defines and go to the load cases. In that load cases, add new case. Give the name as response spectrum. Now select the load case type as again response spectrum. Then we have to add the load applied option. Then acceleration in x direction function as response spectrum. The scale factor formula will be given by Ig by 2I. As you can see that I is the importance factor, that is 1. G is the gravitational due to gravity in mm. Then by 2 into reduction factor is 3. So value will be 1633.5. Then click add for another. This is for x direction. For y direction we have to click again and select y2 response spectrum, and the scale factor would be same, 1633.5. Then check the damping ratio 0.05. Then click OK. After the load case has been defined, click OK. The next thing we have to do is to analyze. Set load cases to analyze. In this, we don't want other dead load and live load. We are doing for seismic analysis, so we are only going to run seismic and response spectrum load case. So click on dead, do not run, live, do not run, and only seismic and response spectrum to run. Wait for the analysis to be done. After the analysis is done, we can view the animation by clicking on the start animation option, and this is the deformed shape. And by hovering the cursor over the 3D model, we can see that displacement can be seen. So for further, we can go to display response spectrum plot. In this, we can see the maximum drift of the floors. So click on the maximum story drift, select case combo as seismic. Then we can see that is maximum drift is for between 9 and 12 story, that is 0.00618, and as per Indian standards the drift value is 0.004, the height of the story. So we are in the control limit. In the same way, we can see maximum story displacements and on. So click on OK, cancel. The next thing, we can see the base reactions. So go to the display, show tables, results, click on reactions and click on base reaction and click OK. I think it is loading. So again, go to design, display, show tables, analyze, response spectrum. Now we're going to see the results, reactions, click on base reactions and click OK. So it is showing the base reaction, that is seismic 1 in x direction, 2 in y direction, and response spectrum base reactions. So various results can be seen. Then after that, we are going to design the model. Click on the concrete frame design, click the revise preferences, see the model is IS code, then design again, concrete frame design, and start design and concrete check. It will take some time. After the analysis and design is completed, we can show the longitudinal reinforcement is shown in the 3D bar. The next analysis is non-linear dynamic analysis. In this we are going analysis for time history analysis. So first unlock the model, then click OK. Then we have to define load patterns. First select the seismic analysis load, modify lateral load. In this analysis we are considering earthquake waves only in x direction, so untick the y direction tab. All the properties are same because the analysis is done on the same region. So then click OK, then and again click OK. Then again going to define functions, then click on time history analysis, select from file option, then click add new function. In this, type the name as time history, then browse the file where you have saved. We are doing the time history analysis of Bhuj earthquake that is occurred in 2001. So browse dot file, yeah, this is the time history data, and click on open. After this is done, we have to click the format type as fixed format to exactly view that graph. So click on fixed format and check. Then we have to select the header lines to skip. So view file. So in this we can see that there are 9 header lines, 1 2 3 4 5 6 7 8 9. So we can skip that. So click on skip 9 header lines. Number of points plus line is equals to 1. So I am going to close this first. So wait for that and click 1. This is the time history function graph. Then click OK. After we have OK, I am changing the name. I want the name as time history analysis, and all the things will be same, and click OK. Here it is, then click OK. After defining the function, we have to define the load case for time history analysis. So click define, then go on load cases. In this we are doing time history analysis, so we don't require response spectrum. So click on that and delete that case. Then again add new case, give the name as time history, load case type as again time history, then add a load applied. In this we are choosing acceleration, default function as time history analysis. Scale factor is same as we have done in response spectrum method. The value will be 1633.5. 1633.5. We have to check the damping ratio 0.0. After that click OK. After the load case has been defined, the next thing we have to do is analysis. To do analysis, click on analysis, set load cases to run, only run time history and seismic run, and click on run now. It would take some time. After the analysis is done, we can click on any point in the 3D tab to view the displacement. In this, we can also display the various stresses like frame stresses, shear, moment again. So this is the moments. Again, we can see the shear force. So now we are going to display the combined story response plot. This select the time history. This is the maximum story drift, tab, displacement, shear, overturning. In this we can analyze our structure. So after analyzing and checking it, click escape. So we have done with analysis. We can again display the story tab. We can again see the base reactions by clicking on base reactions, click OK. So these are the base reaction, maximum, time history, minimum, and this is an X direction. So again we have to do design. So click OK, then again design, start concrete design, click on start concrete design, check. It would take some time. After the analysis and design has been done, we can see the longitudinal reinforcement values here. For again we have to see the reports. Click on the double tab and report. We can see the various reports such as load patterns. I am going to click here reports. It is going to show report in some time. Okay, so these are the reports. Contains total lead load, live loads, base reactions, load patterns, story data, and all. So we can select any report with any values we can see in this, and we can this print this report also. So thanks for watching. This was the assignment for seismic resistant building. Thank you.